This is my beginning algebra course. Today we're going to continue to factor algebraic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by factoring the difference of two squares. So this is a special type of factoring. Now if you multiply two binomials that are exactly the same, and the only difference is that one has a negative and one has a positive, and you perform FOIL, and you come up with this expression, what you're going to notice is these two terms cancel out. So you're going to be left with a binomial. And this binomial is interesting because it's called the difference of two squares. It's always a difference of two squares. You have x squared. Remember, when you raise something to the second power, that means you're squaring it, or that's just squaring it is another way to say you're raising it to the second power. And if you take 9 and change it into 3 squared, you see that 9 is actually a square. Again, we call them squares because you're taking a number, x, and you're squaring it, and you're taking a number 3 and you're squaring it. So whenever you multiply two binomials that are exactly the same, except one has a positive and one has a negative, you always get the difference of two squares. Now you're probably thinking to yourself, who cares? Why do we care about this? Well, when you go into further classes in this course, and courses beyond this course, you're going to have to recognize the difference of two squares, because in many contexts you're going to have to go backwards. You're going to have to take the difference of two squares and factor it into this form. So that's why we care about this. But again, this is just a special type of factoring. So let's do number 1. This is going to be very easy. So we recognize this as a difference of two squares because this is x squared, and if you change this 16, you get 4 squared. 4 squared. So we're going to write two parentheses, or two sets of parentheses, and we're going to write x and x, and then we're going to ask ourselves what number times itself equals 16. Well, I already gave you the answer. It's 4. And we just write a negative and a positive, and that's it. Very easy. So this first concept is going to be pretty easy. Now, if you didn't understand this explanation, you can go back and do that later. Or if you don't want to do it at all, you really don't have to think about it. A lot of students at this level really don't even think about it. The most important thing is that you can factor these expressions. All right, so the second one, we're going to write two pairs of parentheses, and then we're going to write y. And then what number times itself equals 64? What number times itself equals 64? Well, obviously, if you know your multiplication facts, it's 8. And then you just put a positive and a negative. Now, it doesn't matter what side, which pair you put the sign on. You can put a positive here and a negative here. It doesn't matter. You're going to get the same. It's the same thing because of the commutative rule of multiplication, which we learned in my arithmetic course. All right, so let's do one more of these together. So 2 pairs of parentheses. Put your z's. And then what number times itself equals 4? Well, that would be 2. And just put your positive and your negative, and you're done. So this is just a special type of factoring. So why don't you go ahead and by the way, to check your work, as usual, you can FOIL these. If you FOIL these, the inner terms will cancel out, just like these inner terms canceled out up here. And you'll get right back to these terms. So that's one way to check your work. So try number 4, and when you come back, we'll do it together. All right, we're back. So 2 sets of parentheses, put your x's, and you should have 9 and negative 9. So if you got that answer, good job. Try number 5, and when you come back, we'll do it together. All right, we're back. Put your 2 pairs of parentheses and ask yourself what number times itself equals 49, and it's 7. And be sure you write your plus and minus. Try number 6, and when you come back, we'll do it together. All right, we're back. And again, it doesn't matter if the positive is here or here. It's the same thing by the commutative rule of multiplication. All right, so if you got that answer, good job. Try number 7. Number 7 is a little tricky because 1 doesn't look like a perfect square, but as you'll see, it is a perfect square because 1 squared is just 1. So try the number 7, the tricky one, and see if you can do it. And when you come back, we'll do it together. All right, we're back. So x, and what number times itself equals 1? Well, if you said 1, you're correct. And you just put your plus and minus sign. So as you can see, these problems are pretty easy. But let's go to a different type of problem. Now we have problems where there's actually a coefficient on the squared term, but that's no big deal. It's going to be pretty much the same thing. 2 sets of parentheses. And we know that this number is going to give us a 3. What number times itself equals 9? That's 3. But now we have to ask what number times itself equals 4. So obviously that would be 2. So it's instead of y and y, it's going to be 2y and 2y. Now we just put our positives and our negatives. So in other words, you just have to do the same thing on the first term that you do on the second term in the previous problems. So it's no big deal. Now again, if you FOIL this back out, you can see why this works. All right, so let's do number 9. And what number times itself is 9? That would be 3, but we have a variable, so we're going to have to write our z's. 3z times 3z is 9z squared. And then, of course, 4 times 4 is 16. So hopefully you're getting the hang of these now. So why don't you go ahead and dive in and try number 10, and when you're done, we'll do it together. All right, we're back. So if you got that answer, good job. Try number 11, and when you come back, we'll do it together. All right, we're back. And if you got that answer, good job. All right, try number 12, and when you come back, we'll do it together. All right, we're back. And this is a tricky one because we're just going to have 1s there. So if you got that answer, good job. All right, try number 13, and when you come back, we'll do it together. All right, we're back. And there you go. So if you got that answer, good job. All right, so now we're going to go to something slightly different. The only difference really is that the variable is the second term, and the normal number is the first term. So, but it's the same principle. What number times itself is 36? That would just be 6. So you put 6's at the front of the parentheses, the first number in each pair, and then you put your x's and your plus and minus, and that's it. So it's the same type of problem. We're just rearranging we're writing the numbers first, so on and so forth. So let's try number 15. What number times itself is 64? That would be 8. What number times itself is 9y squared? That would be 3y. So we put our plus and minus, and then we're done. All right, so on to number 16. Why don't you try number 16, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Try number 17, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Try number 18, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. All right, number 19. Go ahead and try that problem, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. All right, so for number 20, we've got the difference of two squares, but it certainly doesn't look like a difference of two squares because I'm trying to trick you here. I rearrange the terms. It looks like we have a sum. But if I rearrange the terms and I change it to 9 minus x squared, then you can see that it's the same type of problem that we've been doing before. Now we have the difference of two squares. So put your two parentheses, two pairs of parentheses, and we got 3 and minus x and plus x. All right, so why don't you try 21, and when you come back, we'll do it together. All right, we're back. Rearrange the terms, and you've got the difference of two squares. So if you got that answer, good job. So why don't you try number 22, and when you come back, we'll do it together. All right, we're back, so rearrange the terms, and now we can see that it's a difference of two squares. Put two sets of parentheses, and it's just like all the other problems, or most of the other problems. So if you got that answer, good job. All right, so 23 is going to be a little different. It's kind of a challenge problem. I don't think this problem is that important at this point in your education, but if you see this, I just want you to have an idea of how to do it. So we're going to do the same thing. 9 times 9 is 81, so it's going to be 9, and then of course 4 on the second term, and we need a plus and minus. But here we have z to the fourth power, so we're going to need z to the second power, because z to the second power times z to the second power is z to the fourth power. So I know that it doesn't look like this is a square, but it actually is, because you're taking z squared and you're squaring that. Again, this problem isn't that important at this point, but just in case you see this type of problem, I want you to have an idea of what to do. But we're not done yet, because as you can see, this is actually the difference of two squares also. So we can continue to factor that. And again, this problem is not that important, so I wouldn't really worry about it much. You might see it in the textbook, you might not. All right, let's see here, double checking everything. Everything looks fine. So that was the difference of two squares. As you can see, it's pretty easy. There's not really a lot of work to show. These were the only problems that we needed an intermediate step. So it's pretty easy. So now we're going to do one more thing today. We're going to factor quadratic expressions with two variables. And we learned how to factor quadratic expressions in the last class. But the difference here is we have two variables. We have an x and a y, for example, and an a and a b. It's going to be the same procedure. We just need to make a slight variation. And we're also going to factor the difference of two squares with two variables. We just learned how to factor the difference of two squares. But in these problems, we have two different variables. So let's go ahead and start here. So we learned in the last class that if we have an expression that looks like a quadratic, we just write two pairs of parentheses. Now I have x and x, And then we have to ask ourselves what two numbers multiply to 15 and add up to 8. So obviously that's going to be 3 and 5. But we have y squared, so we have to put 3y and 5y. So it's the exact same situation, except because you have two variables, you have to put these y's here. And that's the answer. We factored that quadratic expression. All right, so let's try another one of these. I know these look complicated, but as you can see, it's really not that big of a deal. And we have 63 and 2. So what two numbers multiply to negative 63 and add up to 2? What two numbers multiply to negative 63 and add up to 2? Well, if you know your multiplication facts, you know it's going to be 9 and negative 7. But we have b's, so we have to write 9b and 7b. Let's try one more of these together. Put your x's because it's x squared. And we have negative 30s. And here there's no coefficient. But remember, if there's no coefficient, it's assumed to be 1. So that's negative 1. So what two numbers multiply to negative 30 and add up to negative 1? So let's see here. I think that would be negative 6y and positive 5y. So hopefully you're getting the hang of this now. Why don't you try number 27? And I just want to warn you that number 27 is going to be a little strange because we have a negative 30 here. And in fact, let's just do that one together now that I think about it. So this one is a little strange because 6 times 5 doesn't work. 6 times 5 is 30, but that doesn't work. 2 times 15 is 30, but that doesn't work. And 10 times 3 is 30, but that doesn't work. So there's a lot of potential factorizations that don't work. So it turns out in this one, it's actually going to be 1 times 30. And it's going to be positive 30b and negative b. It would technically be 1b, but I just put b. Because 30 plus negative 1 is 29. And 30 times negative 1 is negative 30. So that was kind of a weird one. Because this number was so big and number was so small. Anyway, go ahead and try 28, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Try number 29, and when you come back, we'll do it together. All right, we're back. Looks like it's going to be negative b and negative b. That was kind of a tricky one because you just have a's and b's, no coefficients. And you're multiplying a negative times a negative. So if you got that one, good job. All right, try number 30, and when you come back, we'll do it together. All right, we're back. So x and x. And what two numbers multiply to negative 45? That would be negative 9y and positive 5y. Now, if you wrote the positive here and the negative here, that's okay. Just switch the signs, and we'll, instead of getting positive 4, we'll get what we need, which is negative 4. So let me just double check that. Everything looks good. There you go. So try 31, and when you come back, we'll do it together. All right, we're back. Actually, I need a negative there because we have a positive b squared, so that's going to be negative b. And that should be correct. Yes. So if you got that answer, good job. All right, on to 32. Now these are getting a little bit more difficult because we have a coefficient in front of the squared term. So it's not going to be so easy to factor. Remember in the last class, we learned that if there's no coefficient here, we just have to ask what two numbers multiply to this number and add up to this number. It's very easy. But because of this coefficient, that doesn't really work. So, but it is a quadratic. So we know that we have to factor 2. So the only option is 2 times 1. So it's going to be 2g and g. Again, your g's have to come with those numbers because we have g squared in the first term. And then here we have the same situation. The only possibility is 2 times 1. So it's going to be 2 and 1. But again, the h's have to come with it. Now the two numbers have to multiply to make a positive, and they have to add to make a negative. So the only option is for both these signs to be negative. Now I can't assume that that's going to work, because the 2h could be over here. We might have to switch those numbers. We might have to put the 2 over here and the h over here. The 2h, I mean. So if we FOIL this back out, again, we don't have to do F and L of FOIL. We just have to do O of FOIL. But just so I don't confuse you, I'm just going to go ahead and do the whole thing. So F and O I just did, and now I is going to be negative 2hg, and L is positive 2h squared. And move that over a little bit. Positive 2h squared. And so again, the reason we don't really have to do F and L when we're checking this is because we set it up so that F and L would work. So we would assume that those would work. But it's always good to check. Now, if we add these like terms, negative 2gh minus 2gh, you get negative 4gh. So again, these are like terms. GHs are the type of term. It's like saying apples plus apples. So we got negative 4gh, but that doesn't work, as you can see. So we know that we have to switch these two yellow highlighted terms there. So we can get rid of all that. So let's go ahead and switch those. And now that should be the answer. So I'm just going to do O and I of FOIL to double check. So I get negative 4gh, and that's outside terms, and inside terms would be negative hg. And then you put that together, negative 4gh minus 1gh is negative 5gh. And again, it doesn't matter what the order is for you can put hg or gh, it's the same thing, by the commutative rule of multiplication. So that works. All right, on to the next problem. Put two sets of parentheses as usual. And we have 3, so there's only one option for factoring 3. It's got to be 3 and 1. And for 8, we have problems here because there's 2 options. So it can be 2 times 4, or it can be 1 times 8. And of course, one of those numbers has to be negative. So I'm going to try 2z and positive 4z. And I'm going to do O and I of FOIL. Again, I don't have to do F and L. So outside terms is going to be 12xz, and inside terms is going to be negative 2zx. Put those together and you get 10xz. So I got lucky on that one. It was the first try was correct. So that is the answer. But again, you do have to use the O and I of FOIL to check your answer. All right, so 2 sets of parentheses, and we have 5, so there's only one option. You know what? I'm going to do this one later. I'm going to do 35 first. because 35 has a factorable term on the first, has a 4x squared is factorable. That's the first term is factorable. So in this case, there's actually two options for the first term. I just want to get that across. So we could do 4x and x, but we could also do 2x and 2x. So you're going to come across that situation also. So I'm going to try the 2x's. And here we have a lot of options. This is a nasty problem, because we can try 3z and 4z, but we can also try 2z and 6z. That works. And we can also try 12z and 1z. But I'm going to try these, and hopefully this works. So multiply the outside terms, you get 8xz. Multiply the inside terms, and you get 6xz. Add those up, and you get 14xz. So that didn't work. No big deal. Let's try, if we try switching these terms, that's not going to do anything because the first two terms are the same. So that means that 3 and 4, if we assume that the 2's are going to work, the 3 and 4's are not going to work. So let's try 2z and 6z. And let's try to FOIL those out. O and I of FOIL. So outside terms, 12xz. And inside terms, 4xz. And if you add those up, you get 16xz. So you can see that didn't work either. So we could try 12z and 1z, but it's unlikely that that's going to do anything. So we have to get rid of these 2x's and replace them with 4x and x. So 4x and x, and now we'll try again. So let's go back to the 3z and 4z. So now O and I of FOIL outside terms, multiply the outside terms, and you get 16xz. And multiply the inside terms, and you get 3xz. And 16xz plus 3xz is 19xz, so that works. So it looks like we have the right answer. So again, a lot of this is just review of what you did in the last class. The only difference is we have two variables. The only difference is you're putting a variable on the second terms in each pair. So why don't you try number 35, and when you come back, we'll do it together. All right, we're back. And let me test that with O and I of FOIL. Outside terms would be negative 10hg. And inside terms would be negative hg, so that would be negative 11hg, and it works. So I got lucky on that one. My first try was correct. So if you got that answer, good job. Try number 36 and realize that there's two options for 10. It can be 2 times 5 and it can be 1 times 10. And of course, one of them has to be negative. So try 36, and when you come back, we'll do it together. All right, we're back. So that's going to be 3g and g, and I'm going to try negative 2h and positive 5h. So now, multiplying the outside terms, you get 15gh. Multiply the inside terms, and you get negative 2gh. And I got lucky again. I'm getting real lucky today. So that would be 13gh. Now, please understand, if you got negative 13gh, if these combined would be negative 13gh, that's okay. All you have to do is switch these signs. Make this one positive and this one negative. So again, if you get the right number but the wrong sign, just switch the signs. All right, why don't you try number 37, and when you come back, we'll do it together. All right, we're back. You can try 2a times 2a or 4a times a. I'm going to try the 2a's. Then let's see, I'm going to try 3b. Actually, I need a minus 3b. And I should probably make these parentheses bigger. In fact, yes, I'm going to make these parentheses bigger so we can see what's going on. So let's use O and I of FOIL to see if that works. So outside terms would be negative 6ab. Inside terms would be the same thing, negative 6ab. So those combine, that's condensed form of adding two negative numbers. That would be negative 12ab. And we have a negative 20, so that doesn't work. So let's see here. What should we do? We can try to change the b's. Let's try negative b and negative 9b. And let's do O and I. So outside terms, 2a times negative 9b would be negative 18ab. Inside terms would be negative 2ab. And together those would be negative 20ab. So it looks like that was correct, because we want a negative 20ab. So if you got that answer, good job. All right. So that was quadratic expressions with two variables. But remember, in the first part of this class, we learned the difference of two squares. So now we're going to factor the difference of two squares with different variables, two different variables. So we have a square here and we have a square here. And we are subtracting, so that's the difference of two squares. So we just write two pairs of parentheses, t and t, and then we have to figure out what number times itself is 9, so that would be 3. But then there's an r squared, so we just put r's. And of course, because it's the difference of two squares, we just write a plus and a minus. Now, if you're not sure if it's going to work, just FOIL this back out. And if you get to this expression after you simplify, then you know you did it correctly. I should drive that point home. If you're afraid that you're not doing these problems correctly, just FOIL all this stuff out and simplify, and you should get back to your original answer. If you don't get back to your original answer, then figure out what you did wrong. All right, so let's do another one of these. Two sets of parentheses. It's a difference of two squares. What number times itself is 16? That would be 4, but you're going to have to add your a there. What number times itself is 25? That would be 5, but you have to add your b. And of course, it's just going to be a plus and minus, and it doesn't matter what order. Let's see here. So let's try one more of these together, and then you can try one on your own. So I want to say again, you need to recognize the difference of two squares. That's extremely important. You also need to recognize a quadratic expression. Quadratics always have three terms. That's one good way to memorize it. And you always have a squared term at the beginning. And it's kind of hard to say when you have multiple variables. Factoring quadratics and difference of two squares with multiple variables is not really that important, but it is something you're going to see and you will need to do it. So unfortunately, we have to spend quite a bit of time with multiple variables. But this is also reviewing the concept of factoring quadratics and factoring the difference of two squares. So you're going to find that this course is designed to build on topics. You're going to build and build and build and build on the core concepts, as opposed to a very poor curriculum where you just kind of sporadically go from one topic to the next, which is very common in schools, unfortunately. So we have z squared, so it's just going to be z and z. And we have y squared, so it's going to be y and y, and we put our plus and minus. So that was kind of a strange one because there was no coefficients. You can just consider this to be the coefficients to be 1. So again, if you're confused about why that is, just FOIL it back out. You're going to see why it works. All right, so why don't you try number 41? Again, we're doing the difference of two squares. And when you come back, we'll do it together. All right, we're back. So what number times itself equals 4? That would be 2. But we need our r's with those 2's. And then this would just be t, because there's no coefficient, and we need a plus and a minus. So if you got that answer, good job. All right, try number 42, and when you come back, we'll do it together. All right, we're back. I should space those parentheses out a little bit more. All right, so we get 6a and 6a, and negative 7b and positive 7b. So if you got that answer, good job. So try 43, and when you come back, we'll do it together. All right, we're back. So 2g and 2g, and negative 9h and positive 9h. So if you got that answer, good job. As you can see, these are really not difficult once you get the hang of it. That was a ridiculous looking rectangle there. You don't want to be too sloppy with your rectangles. So try number 44, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Again, 10 times 10 is 100. All right, try number 45, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. All right, try 46, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. So that was the class today. Again, we learned how to factor the difference of two squares. It's extremely important to recognize the difference of two squares. You can't use the special methods that we learned to factor the difference of two squares if you can't even recognize a difference of two squares when you see it. That's extremely important. And the same is true for quadratics, which we're going to learn more as we go along. But in the last class, you learned sort of what a quadratic looks like. You need to recognize a quadratic, so you can factor it using the methods that we learned in the last class. A lot of students may not necessarily recognize the difference of two squares or a quadratic expression, so you can't factor it if you don't recognize what it is. Now, we also had the situations where we were switching things around, switching the variables, and we had the difference of two squares where you had a coefficient on both numbers, and difference of two squares where I tried to trick you by making it look like a sum rather than the difference of two squares. Not this one, but so you just have to switch it around. And I don't think you really need to worry about that one, but if you do see it, you can refer back to that problem. And then we went to factoring quadratics and the difference of two squares when you have multiple variables. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Now don't go before you get your homework. There's just 2 pages for the homework, so get a screenshot of page 1 and page 2 here. And again, I have the answers for you. Be sure to check all your answers. There's not really a lot of work that you have to show for these problems, so but you still need to know how to do them. So make sure that you actually do them. Don't just write down the answers. And remember, you need to have your name, the date, the course. The course is beginning algebra. Title your paper. Give a title up there of Factoring Algebraic Expressions, Part 2 homework. And remember, your homework has to have those 4 characteristics. It has to be complete, neat, correct, and in order in your binder. So remember, if you don't do that homework and you don't have all those characteristics, if your homework doesn't have those characteristics, then it's a 100% guarantee that you're going to learn absolutely nothing in this course. Because again, algebra and all math courses are about fluency. The only way that you can get fluency is by doing the math on your own. So get that homework done, and I'll look forward to seeing you in the next class.